on the printer in my office, so I'll show them the difference in them.
Is that one there? Or I think I put it back in the crack because we took it to that.
I think there's another one in there. Open that drawer and see.
The drawer?
Yeah. So, welcome again to the Delmi Training Institute. Today is another day. We're going to continue on the series of electronics. I want to welcome those of you who this is your first time of ever watching us. My name is Roland. Delmi Training Institute is a hands-on technical training here in Woodbridge, Ontario, and in Canada. We have a lot of instructors here, and we train on network cabling, CCTV, electronics and relay access control. We have an extensive amount of programs, and these programs are hands-on, where you get to do it yourself. So we have the do-yourself approach. Not only do we teach you to understand it, but we get you to do it. So our courses are a nice blend of theoretical knowledge and hands-on practice. So as you can see, we're going to talk about the relays and the switches that we were working on. And you can see some of the students are trying something new. They are trying to invent something, and they're just working together. This is just what we do here. They have the opportunity to come here and play with some live circuits. Some of you might have seen Senna and Kwame from some of the previous videos, but anytime they have a spare moment, they stop by here and we allow them to learn and improve upon their knowledge. So there we are. Yesterday I had the opportunity to talk about different types of circuits that we were looking at. This was where we ended up yesterday. And we had two separate scenarios where we had a red LED and we had a maglock. We had a green LED and we had a dot strike. This is in the fail-safe. That's a fail-secure device. And we used a relay. And this relay was connected to an electromagnetic switch, which is a door contact. And this was just what we controlled. We had a 24 volts power supply. We had a 12 volts power supply. We had another 12 volts power supply here. And today we are going to learn how to wire all these things up. So the thing I want to talk about is this. What I have with me is a relay called the RDC12. The RDC12 is a different relay and doesn't look like the typical traditional relays that we spoke about. This relay, it looks pretty much like this, but I'm going to take it apart. When you buy a new one, it comes in a box like that. And this is made by a company called Altronics. There are different relays that are out there, but this one that I want to talk about, by Altronics. It comes in two parts. It has the base and it has the relay module. And the relay module does have the coil and the relay portion on. So when you buy it like this, this is how it comes. And you are able to take this. When you look closely on here, it goes only one way. Just the way the legs are. This side is flat and this guy. So here is vertical, here is horizontal. And so it can only go in one way. Right? With the base, you can interchange this. This is a 12 volt DC coil. But you can get one that is a 24 volts DC coil. So if this is bad, I can just take it out and get a new one and plug it in and it's going to work. This is a double pole, double throw. So let's take a look at the coil properly. You can see it's got two different screws here.
Somebody get some gift or something.
Thank you. You can see another two set of screws here. You see another set of screws and two set of screws. Let's go ahead and understand how this relay works. I'm going to pull up the data sheet and we are going to be working closely with this one today. That is the first circuit we're going to be actually physically wiring. Also, when you take it, it comes with a small piece of paper and we call this the data sheet. This would give you information about this. So if you have it, it's a new one, you can always read and understand it. So for those of you who are watching, what I want you to do if you have that opportunity and you have another phone next to you or you have a laptop with you, what I want you to do is go on Google, like I'm going to do, and see. So I'm going to go on Google right now. And I'm going to go here and I'm going to go back. So I'm going to search for this. This is the name. So it's called Altronics RDC12. That's what I'm going to look for. This Altronics it's a problem. Altronics RDC12. We are going to pull up the data sheet, and together we are going to understand how this relay works. So you guys look up this, go on Google. I'm going to do the exact same thing here. I'm going to go on Google and look at what that is. So here, go back and then search for it. Altronics, NIX, RDC 12. And I'm going to look for the data sheet in PDF. So what I ended up doing, it will take you to Altronics website. It says RDC12, and I'll download that one. So it's downloaded here. And I'm going to open that. Where is that? Altronics RDC12. Probably is this one. I'm going to open that one up. Excellent. So this is that relay. Let me try and make this big a little bit. Christian, why is the zoom on this thing?
Go back. Export, top left.
Oh, this is it, right? Oh, yeah. You know, yesterday I was struggling with this thing. You know, so I'm a little bit old school. I got these young instructors in here, and they actually set this up, and you know, this was the idea. We got the smart TV in, this smart board. It could do so many things. Like, I mean, this board is an amazing board. You could do so many things with this. And when you go to the toolbox, you could do a screen record. You could have a stopwatch. You could go. There's so many things. Like, I do this and it pulls up a camera. Look at that. And you could take pictures. You could do so many things. You could write on this board. It's an amazing board. But let's continue with what we were doing. So these young guys that I have in here, they help a lot with all this tech. I used to be the tech guy, but I think my days of being a techie is no longer there. Okay, so how do I get my screen back, Christian?
It's the other one on the right side.
Oh, which one?
You see beside the home button to the right?
This one?
No.
Oh, this one here.
Yeah.
See.
Should bring up your old tabs.
Yeah, so this I had the whiteboard. It was Explorer. I brought the data sheet, so here.
Just go back to the other.
Yeah, so there you go. Thank you, Christian. Well, this is the RDC12. And let's start from the top. So when you look at this closely, it's just a short data sheet. And it's got a lot of information that we need to know about what we can do with this. It's just the same paper that I have. First of all, it is UL listed. When I talk about UL, I'm talking about Underwriters Laboratory. So UL is an independent testing lab that when a manufacturer comes up with a design and they say this can do that, it's an independent lab. They're going to put it to the test and certify that, yes, it will do exactly what the manufacturer said it does. So when I see just the UL, it's Underwriters Laboratory. But I see another one here. There is a C before it. It has been tested by UL, but to the Canadian specifications. All right, Canada has its own way of doing things. So they want UL to test it according to the Canadian standard. So there's a C there, and it's recognized by that one. When it comes to those of you who live in Europe, definitely they also have their testing requirements. So they get it tested. So this tells you it's also conforms with the European one. So it's got a CE there. The next one is it's a 12 volts DC operation. What this means is the coil portion of this relay is equal to 12 volts DC. And sometimes they have it written on this, but sometimes you cannot see it. But the data sheet is going to tell you. So this particular one tells me that I need 12 volts operation here for the coil. The next is the current draw. How much is this coil going to consume? It's 86 milliamps. Why is that important? It is important because when I'm doing my power calculations, it helps me to determine how many amps in total do I need if I'm using a 12 volts power supply. Now let's look at the type of contacts. It's got 10 amps at 220 volts AC. And we're talking about these on the relays, on the relay portion. So this would switch anything from 220 volts AC alternating current at a maximum of 10 amps. Or you can do 28 volts direct current, also at 10 amps. And it's got the double pole, double throw contacts. What a double pole, double throw contact means is, from what we learned, we have two of these. From those of you who've been part of the class, we have a common, we have a normally closed, normally open, and we have the same thing here, like that. There's a common and normally open, normally closed. And these two are touching. So that just means that this is a double pole, double throw relay. And that is what is in here. It says it here. Now this is DIN rail mountable. For those of you who do not understand what a DIN rail is, we use DIN rails in a lot of industrial settings where you are able to mount this onto a specific unit we call a DIN rail. I'm going to show you guys what a DIN rail looks like. We keep one in class. So this is a DIN rail, right? You can buy, they come in, I think it's about 7 feet. So I'm 6 feet, 6'1", so this is about 7 feet. That's just what they come in. But you can buy them and you can cut them to whatever specifications. So if you have any equipment that is DIN rail mountable, it just means that you can mount it like this. So on this rail, you're going to secure this and take that. It just clips on the top and you just snap it in like that and it would stay. They have different equipment that are also DIN rail mountable. So if you want to mount something, you can check to see if it's DIN rail mountable. To take it off, you have to just pull this and it comes from it. So this already tells me it's a DIN rail mountable, meaning that I can mount it on a DIN rail, or it comes with screw holes here that you can use a screw to fasten it to whatever you want to do. Next is this. They tell you the dimensions of this. So even before you go on the field to go install this, you know these are the dimensions. And if you have to install it into a specific space, you can tell whether it's going to fit or not before you go there. So as we continue with this, they tell you a few things about the installation instructions. What they tell you to do first is They're telling you to mount this in whatever desired location you want. Plug the relay into the base. So after you've mounted this, you're going to plug the relay into the base like that. And just squeeze it. And it becomes one unit. And then the relay would activate upon applying 12 volts to the terminals marked 7 and 8. So let's look on this. This is 7, and this is 8. So when I apply voltage to these two terminals, the relay is going to activate. Meaning that when I look at this, pin number 5, it's a common, right? You can all see this. Pin number 5 is the common. The same as pin number 6. It's also a common. Pin number 1, it's a normally closed here. Pin number 2 is a normally closed. And pin number 4 is a normally open. Pin number 3 is a normally open. So let's look at what is unique. Because this is a double pole, double throw, this common, this and that is one form of the circuit. This common, normally open, normally closed, is another separate circuit. So what is going to happen here is if I, for whatever reason, introduced a voltage to this terminal here, let's say 12 volts DC. Thank you. If I introduce 12 volts DC here, we learned that this common is always in contact with what we call the normally closed. And when I look here, this is the normally closed. So there's a direct connection between this and that, like this. So if I introduce the 12 volts here, on this terminal, I'm going to see 12 volts DC. This is going to experience nothing. In the same way, if I introduce the different voltage here, and this is 24 volts DC. What is going to happen is there's a direct connection between these two. So this 24 volts that I brought here, I'm going to see 24 volts DC here. Nothing is going to be on these normally opens. The normally open is going to see voltage only when I apply something to these two terminals. So if I introduce a separate voltage here, then the voltage that is coming here is going to move here. And there's going to be nothing here. In the same way, this is going to move here. So whatever voltage I introduce here is now going to be here. So that's how this relay happens. One mistake that I see a lot of people do with this type of relays, when they bring the 12 volts to this terminal, they're expecting to see it on this one. It doesn't work like that. This is separate. This is separate. The only thing that is not separate is this coil. And this coil, like I said from previous tutorials, if you have the relay with a coil like that, it's got that soft ion in there. And what they've done is, this is your relay portion. Right, that's your relay portion. So anytime you introduce something plus 12, here you introduce voltage from here in the ground, this soft ion becomes magnetized. The moment it becomes magnetized, because there is this metal attached to it, it's going to attract it to itself, and that way My bad, I drew it wrong. Let me fix this. I'm going to connect this to this like this, and this to this here, so that this way it makes sense. So this is normally closed, normally open, normally closed, normally open. Good. So once it attracts the metal to itself, this pole is going to move here and come to the normally open. When I take the power away from the coil, this is going to go back because it's no longer a magnet. When I introduce voltage, it becomes a magnet. It attracts this to itself. That's just how it does by switching the voltage between here and here. That is how this one works. So if you decide to use 1/2 of the circuit for your 12 volts, remember to use the common and the normally open and normally closed. Oh, sorry, normally closed and normally open for that. And if you introduce 24 volts, make sure to use this and that. That is the unique thing about this. So I'm going to take one of these, I'm going to wire it up, and we're going to see how that works. So this is just pretty much the end of it. They're so good enough that they put a phone number here and a fax number and an email. This has a lifetime warranty on it. If you have issues with that, be kind enough, call them, and they'll be able to help you out. So I'm going to go to my desk. First of all, I'm going to tell you what we're going to do in terms of the lab, and I'm going to wire it up. So what I'm going to do is I'm going to take a switch. You guys tell me, what input device should I use? You know, yesterday we learned about input devices. You got to tell me, which one should I use? Should I use a door contact? Should I use a wave sensor? Should I use a mechanical button? Should I use a Form A switch, Form B, Form C? You guys tell me, what do you guys want me to use? Thank you. You guys rock.
Wave sensor.
Okay, so wave sensor it is. So what I'm going to do is my input device, the white one always pops, right? So my input is going to be a wave sensor. And I'm going to use the RDC12. Oh, and there's one thing I forgot. When you take this relay, right, for those of you who have very good eyes, and you take this, on each terminal, they've written a number on it. So number 1, 2, 3, 4, 5, 6, 7, 8. What this means, you can see a small number written on the side for your own reference. So we have these ones as the normally what? What was it? Those ones were normally based on that. Normally closed. This is also normally open. This is the coil. And this is the common. Good. So this is the relay that we're going to be using. Now I need you to tell me what output devices you guys want me to use. So let's talk about output devices. Output device 1. What is my output device?
LED.
So what color? What color LED?
Somebody said fans.
Okay, so there's going to be a fan. So I have one fan.
Red.
Red LED. Someone said a fan. So first of all, let's go back to the LED guy. What voltage do you want me to use for the LED? I think the LEDs, the ones we have here, they're 12 volts. Do we have any 24 volt LEDs here?
Somebody said 12 volts.
Okay, so let's use 12 volts for the LED. So LED 12 volts DC. The fan, 12 volts DC. What else?
Somebody said 30
No, we're not going to go into high voltages here. So what about I use a 24 volts door strike?
Drop bolt lock.
Yeah, so I'll use the strike for it. So the strike, we'll do 24 volts DC for the strike, right? We're going to do 24 volts for the strike. I need 2 more or 3 more. What do we have? For output device? What about I add a green LED?
12 volt motor. Buzzer. 12 volt door alarm.
Okay, so I'm going to, someone says a buzzer. So I'm going to use a siren. And I'm going to use the last one. You said someone said what?
Thermostat.
Uh, so I have a red LED, I have a fan, I have a door strike, I have a green LED, siren, and you know, why not use a maglock? A maglock will be interesting. So that way you guys learn how a maglock works too. So I'm going to use a maglock.
Fail-safe lock, somebody said.
Yes, so fail-safe is a maglock. That's fine. So maglock is a fail-safe.
Jerry is commenting that.
Oh, Jerry commented. Hi, Jerry, how are you? So this is 12 volts DC. We have the siren, and the siren is 12 volts. And the green LED is 12 volts. Okay, so the only one we're going to do is the door strike at 24 volts. That makes us out well. Now we have all these devices. Whoever said the door strike, the red LED, whoever said the red LED, I want you to tell me how you want the LED to perform. So in the default state, without me waving on the sensor, how would you want this red LED to behave? Would you want that red LED to stay on, or you want it to be off? And then when I wave this sensor, it's going to toggle that.
On.
Okay, so you want the red LED to be on all the time, but when I wave, and it goes off. Perfect. So this always on. So the red LED is always going to be on. The only time it's going to go off is when I put my hands on the wave sensor and keep it there. Okay, so we got that. The guy who said the fan, how would you want the fan to behave? Do you want the fan to stay off, and when I wave, it's going to turn on, or you want the fan to always be on, when I wave, it's going to go off? How do you want it? For those of you who said these ones too, prepare your answers for me.
You said off. Yeah, just say off.
Okay, so the fan is going to be always off. When I wave my hands on the sensor, then the fan will turn on. Okay, what about the door strike? It's 24 volts.
Fan always, somebody said, off when you wave.
So, you said what? For the strike?
Yeah, I think
What did they say for the strike?
off when you wave.
Okay, so the strike is going to be locked. When I wave, then it's going to unlock. Okay, so strike is always locked.
For maglock, when there is no electricity, the maglock acts as a fail-safe.
Yes, no electricity, a fail-safe, L-O-C-K-E-D. Always logged. What about the green LED? How would you want it to behave? So with the green LED,
Some guys said off.
so the green LED is going to be off. Only when I wave the sensor, then it turns on. So green LED off.
When door opens, it's on green.
Okay, so because the door is locked, so once this is unlocked, the green LED turns on. That's a perfect logic. Senna, thank you. We'll see you tomorrow. It works? Okay, tomorrow you explain to me. Then we have the siren. So what do you want the siren to do? Do you want when the door unlocks, siren should go off, or the siren should always go off, and then when someone waves, the noise should stop?
Siren off always.
Off always. Okay, so siren is off. And what about the magnetic lock? Because remember, the magnetic lock, if it's off, and when you wave and it locks, it doesn't secure your door. You want your door to be secured when you wave and then it unlocks. But you tell me what scenario. We're all learning now. So whatever you want, we're going to wire it that way and you're going to understand.
For maglock, when there's no electricity, the maglock acts as a failsafe.
Yes.
On.
Okay, so you want the maglock to be on. Perfect. So this is the scenario. When you look at this and you go like, wait a second. I have so many devices that I want to control. I have a red LED, and I want that red LED to be always on. Thank you. So what I'm seeing here is two separate voltages, 12 and 24 volts. So I am going to decide that with this relay that I have, which of the portions am I going to use for 12 and which side am I going to use for 24? So let's assume that I use this side for 12 volts and here for 24 volts. So anything that is 24 volts, I'm going to connect it here. Anything that is 12 volts, I'm going to connect it here. Let's make this a little bit smaller so I can fit everything into it as we continue to draw. I'm going to shrink it a little bit. Okay, perfect here. I'm going to take this and bring it here so I can be able to do some stuff again. And I'm going to move this here. Output devices. I'm going to move this here. And I'm just going to make it a little bit big here so you guys can see. Perfect. Now with this wave sensor, you also have to, because it's an input device, you have to determine what voltage you're using. But first of all, you have to look at the data sheet. The wave sensor that we're going to be using here looks like this. Wave. But like I said, it's an active device. So we have two for plus and minus. And we have this. One is the normally open, one is normally closed, one is common. So this is a typical wave sensor. This wave sensor operates on a 12/24 volts DC. For this terminal, we have to look at the data sheet and use that. So let's say we're doing the 12 volts. Then definitely I need a power supply here, PS 12V, plus minus. Okay, so that's the wave sensor portion. So let's look here. What I want to do is I have a red LED. This is the red LED here. And it's at 12 volts. Also, what I do is I have a fan. Let's draw the fan here. The fan also has a terminal plus minus, just the same way this one does. Plus minus. Now next I have a door strike. I'm going to draw my door strike here. This is the door strike, right? The door strike also has a plus minus. This is 12 volts. No, the door strike is 24. This is 12. This is 12. Next I have a green LED. So I'm going to draw the green LED here. That is also what? 12 volts. Next, I have the siren. This is my siren. Siren is 12 volts. It's got a plus and a minus. Then finally, I have a maglock. The maglock is 12 volts. I'm going to draw my magnetic lock. So let's draw the maglock here. It's got two pieces of metals. One is the armature, one is the coil. So this is the one that has the coil in it. And it's got two. It's got a plus, minus. This is the mag lock. Perfect. So we have all our output devices laid out. This is what you want to do. And now we're going to try and understand the logic. Let's take the red LED first. With the red LED, when it's 12, we want it to always be on. So this light, we always want it to be on. But it's a 12 volt DC power supply. So we're using the left here for 12 volts, and we're using the right for 12 volts. But what we have to consider is, we want this red LED to be always on. So since it's 12, I can use a power supply that has enough current to power up all these 12 volts DC. So what I'm going to do is, I pull up the data sheet for this, pull up the data sheet for the fan, pull up for the LED, the siren, the maglock, just from how we did here. And it's going to tell you what the maximum current draw on each device is. I'm going to take the current and I'm going to add the current for the red LED, the fan, the green LED together. If let's say I added them and it becomes 1.2 amps, then I need a power supply that is 2 amps, right, at 12 volts. So this is enough to do that. What I'm going to do is, remember, I need this 12 volts, the positive of this 12 volts. From here, I need to connect it to the coil of the 12 volts. And the moment I did that, this 12 volts that I introduced here is showing up here because this is normally closed. So let's look at the logic for the red LED. I want this red LED to be always on. Now, here has no voltage, but here has voltage because of the voltage I brought here. So if I want this to be always on, then I have to take the terminal. I have to take the terminal from the positive and bring it all the way and connect it here. Because by connecting it here, this is automatically going to get power and it's going to turn on. Don't worry about the negatives. We're going to connect all of them after. Let's go to the next one. That is the fan. It's 12 volts. We want the fan to be always off. You see, at this time, I haven't even said anything about the input. We're talking about the output yet. So I want the fan to be always off. But when we look, the fan has a voltage of 12. So we have to come and look on the 12 volt side. This has always electricity, but here there is nothing. So if I connect the fan here, nothing is going to happen. The fan is going to continue to be off. So it just makes sense that I take the positive of the fan and connect it here. Does it make sense? If what I'm teaching makes sense, thumbs up. Thumbs up, a lot of thumbs up.
Lot of them. So we're going to create a WhatsApp community group as well, so that they can ask questions and see the update about the light.
Oh, okay, so that's great. You see, this smart guys in here, they just said we have to create a WhatsApp community, and this is going to be a community of all the students who want to learn, and we're going to be posting stuff. But one thing I don't like about WhatsApp is when you create a WhatsApp group, people start posting all kind of stuff in. Unfortunately, that's not one thing I want. It has to be educational. So we're going to be posting things about this. If you have any questions regarding some of the tutorials, you're going to ask in there. Instead of just posting videos and any comments, no, we don't want that. So if we're going to be creating a WhatsApp community, it has to be very strict and nobody can just post anything, so that we can all learn and learn something good. So good.
We'll give them at last the link.
Okay, so the guys are saying they're going to give you a link at the end of it. Now let's look at the dot strike. The dot strike is different because the dot strike is 24 volts. So as a result, I have to use the right side because that is where my 24 volts is working, right? So now let's look at it. It's 24 volts, but I want it to be always logged. If you understand the principle under which a door strike works, Christian, give me a fail-safe and a fail-secure door strike. So I have a fail-secure, give me a fail-safe. So look at this. This is a door strike and has no power coming to it. However, the strike is logged, right? You see, I cannot open it. I've instructed Christian to get me another strike, and I'm going to show you. When you apply power to the power terminals, this is going to unlock freely, because this is a fail secure. So without power, they want it to be logged. Look at this one too. Thank you, Christian. Look at this same one. There is no power connected to it, but look at what is happening here. It's unlocked. So this is used for safety equipment, like when you're wiring something that needs to be safe. This is what is going to happen. When there is no power, it is unlocked. When I apply power, then it's logged. So when I'm designing a system, I want to connect it to this door, and this is an emergency exit. And when there is power failure, I want this door to stay unlocked. Or in any emergency situations, I want the door to automatically unlock. Then I have to change the strike to a fail-safe mode. And some of the strikes, they allow you to make that change on the back. So you have to also look at the data sheet. The data sheet is going to tell you how to convert the strike from a fail-safe to a fail-secure. Remember, it is not all strikes that can do that. So you check the data sheet and make sure that the strike you're using supports that. With this particular one, it's made by HES, Asa Abloy. All you have to do is to unscrew these two and just shift the screws from the lower port up and retighten them, and you just change the configuration of that from a fail-safe to a fail-secured. So with this one, this door strike, it's fail-secured, meaning that when there's no power, they want it to be logged. So when I look at this, door strike is 24. The same thing when I have a power supply here, 24 volts DC, plus minus. When I take this positive from the power supply and I bring it to the common, let's look at what happens. This 24 volts that I brought here right away comes here. It's connected there. But I don't want this strike to be receiving power. I want it to always be logged. So if I connect it here, right away the strike is receiving voltage and it's going to be unlocked. So instead of that, I can take the positive of this strike and I can connect it here because there's no voltage there. So this has no power and it's going to stay logged. I hope you guys are understanding. So we're going to the green LED now. The catch here is this is 12 volts. So if I have to do any wiring, I have to do it on this side. I want the green LED to always be off. Now when I come here, here is on, here is off. So this green LED is going to behave exactly like the fan. So when I take the green LED from here, the positive, I can take that positive from here and I can just connect it here. Or I can bring it all the way here. But it's just easier for me to connect it here, like that. For those of you who want, you can bring it all the way and connect it to this terminal. Now let's look at the siren. I want the siren to be off, but it's 12 volts. So the same thing, siren is working at the same as the fan and the green LED. So this is my siren. So I can also take the positive from the siren and connect it to here, because they're all going to go back to the same terminal. Let's look at the maglock. It's 12 volts DC. but I want that to be on, meaning that I want to send power to it. This one here has power, and that is acting as this one. So what I can just do is take the positive from here, and I can connect it here because it's coming all the way to this one. So now you guys notice how I have wired all the positives. Now I'm going to focus on the negatives. All the negatives that are 12, I have to bring them to the same power supply that is here. So I'm going to take black, and I'm going to take the power supply from here, right? Take this power supply. I'm just going to take it up here from here, just to make it clear. So that's my negative. I'm going to take this negative from the 12 volts, connect it to that. What again is 12? The fan is 12. So I'm going to take it from here and connect it. This is 24, so I cannot connect it to that black line. But I take this 12 from here, connect it to this maglock, and continue from here and connected this. So I've connected everything that has to be 12. The red LED, the fan, and this one also. And connected. So pretty much, because I'm just connecting them here, I could have just brought everything to this terminal here. That's fine. This is just one wire that is going. For the circuit simplicity, I don't want to have too many lines going back and forth. Next, I have to deal with the 24. This is the 24 volts. Where was it getting its power from? See this positive came here, it jumped here, it would come out from here to the 24. So I have to make sure that the 24 volts is connected, the negative from here, all the way to this 24. Now everything on my output is wired completely. Let's look at this coil, for example. The coil is 12 volts because when we looked at the data sheet, don't be tempted to say you're going to take this 12 volts and just connect it here, and you take the negative and connect it. Once you connect it directly, everything here, this is what is going to happen. When I bring positive and negative here, this power that is currently sitting here is going to move here. And once the power comes here, this strike is going to be unlocked. The fan is going to already be spinning. The green LED is going to be on. The siren is going to be on. The maglock is going to be off. And that's not what we want. We want to be able to interrupt this. So how are we going to do it? First of all, I'm going to take the positive because this wave sensor is an active device. I'm going to take the positive from here, connect it here. And I'll take the negative of the wave sensor, which is this line that is going here. I can interrupt it and connect it here. This one, and I can interrupt it here. So I've connected this positive and negative. So now this is on. It's just like you turn on the accessories in your car. The radios and everything is on. So now I have activated this guy. The next thing I want to do is I want to be able to bring the positive 12 volts here. I want my 12 volts to be here and my negative, my ground should be here. So what I'm going to do is this same power supply that I used to power this guy out, I did my power calculations. I can take it from here, or I can come to the power source and take it from there and bring it all the way to the common. Based on this principle that we've learned from here, when I bring it to the common, right away the voltage is going to come here to the normally closed. And it just makes sense that if I take it from here and I connect it here, it's just going to be like I took this and I connected it directly here. Everything else is going to start working the way it's supposed to. So when I look here, there is no voltage there. The only time the voltage is going to show up here is when I wave. When I wave, it's going to leave here and come here. So it just makes sense that if I want the wave to activate this, then I have to connect the output from here. So what I'm going to do is I'm going to take it from here and connect it here, right? And then this is the negative. So from here I can take this because that's the opposite end of the coil. I'll take this. So I'll take this here. Why am I getting that? Let me see. Select black. There you go. So I go from here and here. So now this is what I've done. I've wired everything. So let's look at it. There's the 12 volts power supply here. It's brought the voltage here. It's activated this wave sensor. I took the same 12 volts from here and I brought it to the common. That 12 volts is now sitting here. The 12 volts is now sitting here. Nothing is connected to it, so I really don't care. But when I wave, it's going to transfer that voltage from here to here. And the voltage is going to come all the way to the coil. Now the coil is receiving voltage. And once this receives voltage, I brought 12 volts to the common, and I brought 24 volts to the common. So the moment I energize the coil, this voltage that I brought here that was sitting here, the normally closed, is now going to switch to the normally open. Now once it comes to the normally open, what is connected? The fan fires up. The green LED fires up. The siren fires up. Those are the things. The red LED is connected here. So now the voltage is here. So the red LED is getting nothing. So it stays off. What else? The maglock. When you look at the maglock, look. It goes all the way here. It's not receiving anything. So since no power, it's no longer a magnet. It separates. Now let's look on the 24 side. This voltage that was sitting here now comes here. What is connected to it? The door strike. The door strike now receives power. And once it gets power, it's going to unlock. So that's just how easy it is. So first of all, before you do anything, list all your output devices. Think about how you want it to work. And you are going to connect it to the different... Kofi, can you take this guy's call? Yeah. Right, so that is just how you do it. You wire everything to your relay and then come here and do this. I have to tell you something though. You can wire it to the normally closed and reverse everything here, right? If you reverse everything here and you wire it to the normally closed, which means that you are bringing this and taking it here. There's always going to be electricity running at the normally open. So that's when you're going to wire it. But what are you doing? Your system is consuming so much electricity by doing it like that. And also your devices could fail earlier. So it's not advisable to always be sending electricity. There are specific applications where you can design your system like that. But once we understand this, that's where we're going to go. All right?
Someone said they're confused with the negative connection of the input device to the relay.
The negative connection, this one here.
Of the input device.
Yeah, I think I have that one.
So it's 12 volts. And remember, when we pulled up the data sheet, this particular device is non-polarized. So the data sheet makes it aware that it's non-polarized. So the coil, I can either connect a positive here or a positive here. It really doesn't matter. This is a positive, so I decided to pick this as my positive and that my negative, right? Or I could have brought my positive here and brought my negative here. The specific guy who designed this really didn't care about polarity, right? So that's just what it is. You can use here as positive or negative. They're interchangeable. So for this coil to be on, look at what I did. I did not want to connect the power directly here. But I took the power, brought it to the common, and then I want it to only activate from the normally open and come all the way here. Now the negative, look at the negative. It just goes all the way and comes back to the negative terminal of the power supply. Did I explain that? Whoever asked that question, are they good? So,
Yeah, he's good. He said okay.
So it's, you see how fast the time goes? It's 1 hour already, right? So you guys take a screenshot of whatever this is.
No, we will send it on WhatsApp channel. That's
Oh, okay, perfect. So even better, they're going to take a picture of this. They're going to put it in the WhatsApp group. And
we'll display the link there afterwards.
okay, we're going to do it. So what I wanted to do was I wanted to come here and wire up everything that we have just drawn here and going to see how it actually behaves. So we have the green LED there, we have the red LED, we have the wave sensor. On here we have a wave sensor here that we're going to use. We have the siren strobe, we have the siren right here. The maglock, we have the maglock in the student's kit. The door strike, we have the door strike right here. And we have another one here. So we are going to be wiring all this so that we could see how all this works, right? Unfortunately, when you're having fun, the time goes so fast, right? It's already 1 hour since we started this live. So what I'm going to do is tomorrow, same time in class. Don't be late, please. Do not be late. We are going to be here. So I'm going to spend the next 10 to 15 minutes answering questions. And then after that, we're going to put the WhatsApp information here.
And we'll display at what time we go live as well.
Oh, exactly. So in the WhatsApp group, part of the things that we're going to do is we're going to be displaying or making announcements when we're going to go live. So that this way you don't have to be guessing, oh, when are they coming? At least in the mornings, we'll put it in and say, this time we're going to go live. And you guys can be well prepared for it. I hope this today's lesson was very informative. And I was able to break down things for you guys to understand. Let me know where you're watching from. Right, that's
338 people are watching.
338 people. I really appreciate that. I believe that you guys learned a lot. That's what we want to do here. We want to break down the barriers. We want you to be the best version of yourself. So when you get a job and you have to do it, you understand the knowledge. You have the knowledge to be able to do it. So also what we're going to do is, Christian, part of the WhatsApp group for today, all the part numbers for this,
Find them and
just find them and just drop them in, like today's lesson.
Use of the relay because
is the use of the relay because you have two different voltages?
Yes, I use that perfect because this guy definitely he's been following the class. So if I had just one set of voltage, let's say 12 volts, the first thing I have to do is I have to pull up the data sheet. And the data sheet is going to tell me the maximum current. It's very important. You just don't take any relay and start sending current on it. This one told me that I'm able to do, what was it? A maximum of 10 amps of current on this particular one. Some of the other relays wouldn't give you 10 amps. For example, I have a different type of relay, I believe, here. This is another set of relay. Let me pull it out and we're going to compare that. So this is another type of relay. It's called the RBST. It's a double pole, double throw, but the form factor is different. When you take it out of the box.
Should I put that link up for a little bit?
Yeah, you can put a link out for a bit. You want me to do something?
No, just be on the phone, I think.
Oh, can we put it on the TV?
Yeah, can you grab the HDMI adapter there? I think I just threw it up there.
The green one?
Yeah.
I think we were using it on the laptop yesterday.
Oh, it's on this. It was on this table.
Yeah, when I was cleaning
But I
them,
think, yeah, you cleaned it.
Okay, whilst I continue to go, these tech support guys are going to try and tech support themselves. So this is, the boxes look identical, right? Look at that. Same company, they look identical. That is what they all look like. But they're different. You just got to read what is on it. So the one that I have is the RBST. I don't know too much about this relay, but I can find out in as little as 5 minutes. When you take it out of the box, you have the relay module, and you have two breakaway sticky modules. So they break apart. And the reason for this is you're able to stick them on the back here, so you don't short circuit these when you mount it in a metal enclosure. Because all the terminals are showing when you stick it out, you don't short circuit it. So let's try and understand a little bit more about this relay. And the part number for this one, I'm also going to put it there, and you can pull it up, and you can look at the data sheet yourself. It's the Altronics.
Where can I get those relays?
I think you can get them sometimes on Amazon, and it depends. We usually get this from places like ADI, Wesco, most electronic distributors here in Canada. So that will be your APA, your Wesco, your Secan hardware agency. It's now Secan. You can get all these things from them, or you can just Google it and you see, based on where you are, you should be able to get one of them. This is the RBST, the Roger Bob Sam Thomas. When you look at this one, for example, this is slightly different. It will do 6 volts. Let me do this properly so I can write something here.
yeah. I think it's RBSN.
This one is RBST.
RBST?
Yeah.
Yeah. But if you go to HDMI2, you'll see that WhatsApp link there.
Oh, okay. Once I go, then I click it. Okay, I'll just explain this one here. So this, as part of the data sheet, it's 6 volts DC or 12 volts DC or 24 volts DC. Just means that this relay can work using 6 volts. I'm talking about the coil. Okay, the coil that we looked at, the other one could only use 12 or 24. No, just 12. That other one, strictly 12. But this one will do 6 volts, it will do 12 volts, it will do 24 volts. So depending on the voltage that I have for the coil portion, and when I talk about the coil, in this situation, I'm talking about when I look at this carefully, it says the positive is here. POS and negative is there. That's just what it means. Positive and negative. So at those terminals, I can use either 12 volts, 6 volts, or 24 volts. But let's look at the double pole, double throw contact. It is 1 amp at what? 120 volts AC. Or 2 amps at 28 volts DC. Look at this. So this is for small applications. If I'm using 120 volts AC at the double pole, double throw terminals, the maximum current I can use is 1 amp. If I'm doing anything up to 28 volts, the maximum is going to be 2 amps. So you notice how from here, I have all these devices connected to it. The red LED, the fan, the this, the that, the that. What I have to do first is I have to look at the data sheet. How much current is this consuming? How much current? How much current? How much current? How much current? So I add up the total current. And if it exceeds 2 amps, then I could damage that relay. So that relay is going to be appropriate. So you see how the data sheet is important. Sometimes you might say, when I connect the stuff, as soon as I connect it, it stops working. because you might have been exceeding the current. And it's of no fault of yours because you don't understand data sheets. But now that you understand data sheets, you take everything, look at what you're able to switch. What other information is there that is useful? Okay. It says the relay is factory set to 6 volts. So relay, factory set to 6 volts. So when I take it out of the box like this, for me to have this to work, I have to connect 6 volts to the positive and negative. What if I want to connect 12 volts instead? It tells me if I want 12 volts, I have to cut jumper 2. Right? So let's look for jumper 2. When you look on this one closely, you can see there are 2 jumpers here. Jumper 1 and jumper 2. They are here. So if I want 12 volts, then on the board that has jumper 2, I have to cut it. And the moment I cut it, it becomes 12 volts. What if I want 24 volts? Cut jumper 1. There is jumper 1. So the moment I cut jumper 1, now I'm able to apply 24 volts to the positive and negative. Remember, if you do not cut the appropriate ones and you apply 24 volts to it, you are going to fry this. You're going to damage it even before you're going to use it. So these are just some of the most important things that the data sheet is going to teach you just by taking it up. So don't make that mistake. These things can be expensive. You don't want to damage them. So these are just some of the things you need to know. Questions?
Yeah, some guy said, what's your thoughts on incorporating a fuse on the diagram?
Oh, incorporating a fuse on the diagram. Yes, you can incorporate a fuse. So what a fuse does is it protects devices or equipment on your circuit board. So when you draw that and let's say the current is either overloaded or you're going to send the current the wrong way, the fuse is going to take the hit and the fuse is going to blow instead of that. So yeah, definitely we could do that. But since what we're trying to focus on is the very basic stuff to make people understand how these things move, I want to make sure that everybody understands it and that we keep building on it slowly and slowly and slowly. If I start incorporating things like fuses and all those stuff, people are just going to be confused. And also, this is the electronic class for electronic security and access control. So what we want to make sure is students who are going to be working on access control devices, they understand the fundamentals of how to connect an access control panel, but use it to control both a door operator and a door strike at the same time, adding visual indicators. So when the truck driver is coming to the gate, he sees a red light, it means that do not approach. If it's a green light, you've been given clearance to approach. So things like that. That's just what we're trying to do. But yes, definitely a fuse integrated in that could prevent equipment from damage. Any other question?
Will the wave sensor work will the siren work when I have a wave sensor?
So based on what we drew here, let's look at it again. So we have this. Let's go back to this and see. I'm going to trace it all the way back. So from here, I'm going to go all the way and follow it. So now this is connected. The wave sensor is connected to a normally open. But the voltage that I brought here is sitting at normally closed. So in the ideal state, the siren is going to be zip, no noise. When I put my hand on the wave sensor, this is what is going to happen. The positive voltage from here, since it's coming this way to the common, at this time it's sitting here and nothing is connected at the end of the common. If my hand is not there, so the voltage is sitting here. When I bring my hand in front of the wave sensor, the voltage that was sitting here is now going to move and come here. And my hand is there. So that voltage is going to flow through here, come here, there, all the way to the coil. The moment this coil senses voltage, this other voltage that we brought here that was sitting here and came here. Now it's going to move because my hand is still in front of here. This voltage is going to move here. And once it moves, the electricity, I brought it here. And that electricity is going to flow all the way. You see it's going to come to the siren. It's only at that point that the siren is going to go. If I take this off, the siren stops. If I bring it back, the siren goes off.
And then just last one, I guess. How can my mobile phone be an input device?
Your mobile phone, so then you have to take, so we have on, you can find them on Amazon, on Temu, on all these places, AliExpress. We have an RF module. You could use your cell phone as an input, either by Bluetooth or whatever wireless frequency you want to use. So you can buy these little adapters, and they've got a relay integrated in it. So they're going to receive signal from your cell phone, and you're going to connect the output of those relays to control all these. So that's, you have to get an adapter for it. And they sell them on all these different electronics hobby sites. You can get them. But first of all, you have to understand how to connect all these. It could be light switches. It could be different output devices. You have to understand how to do it. And your input device here is going to be your cell phone, connecting to that module. I'm going to take one more question. And is there any more questions?
Yeah, so I guess the last one would be the same coil can be able to take 12 volts and 24 volts at the same time?
So this coil here, for the coil that is here, based on the data sheet, again, you notice that how when you guys ask me any question, I go to the data sheet. I don't want to tell you yes. Because based on this data sheet, the coil is only 12 volts. This particular relay that I'm using, it's only 12 volts. So I cannot apply 24 volts. The moment I apply 24 volts here, I'm going to blow it. So you have to look at the data sheet. It's only rated for 12 volts. So I have to make sure that the power supply I'm using is 12. If this relay was rated for 24 volts, and I have a 12 volt power supply powering this, then it makes sense that I look for the 24 volts power supply from here, and I use that to power the coil. All right, so we're going to put that on here. This is the QR code for the WhatsApp group.
Is this training certified?
Yes, it's certified. You get a certificate at the end of each course module. So like I said, we have 4 course modules. We have network cabling, we have CCTV, electronics and relays, and access control. So when you complete any course module that we offer here, you get a certificate. And we also train on safety. So working at heights, fall arrest, WMIS, 4-step awareness. You get a certificate for all these courses as well. And we are well known. All these big brands, these big corporations, they come to us to hire, right? So we are a trusted source